I'm the general manager of underwater glider systems, so I'm responsible for all aspects of development, manufacture, and sales of our sea glider product line. Very happy to be showcasing two of our new sea gliders. We have the Sea Glider C2, which is a vehicle that's optimized for shallow water operation to 200 meters depth. We also have the Sea Glider M6, which is optimized for deep water operation down to 6,000 meters. So that's the only commercial glider out there right now that can do that deep of operation. So it's pretty exciting to have that available to our customers.
Okay, so sea glider technology obviously has been around for a while. What is it specifically about these models that make them unique or different in the market?
Yeah, that's a great question. The C2 has a very wide range of buoyancy, or variable buoyancy system, 3,500 cc's, which is about 4 times what the original sea glider had. So there's a couple things that allows you to do. It allows you to generate more forward velocity, and so you can combat high currents, relatively high. We're talking glider speed here, right? The typical glider may be able to achieve about 3/4 of a knot in speed. This glider can do over 1.5 knots, so it's about twice what a typical glider would do.
Okay.
So that allows it to combat those currents. But in addition to that, that wide range of buoyancy allows it to operate in basically from fresh water to salt water without having to change the physical ballasting of the system.
Okay.
So it's a lot easier to pick it up from one place, go to another, and just drop it in. You don't have to do any work on the vehicle. Or perhaps you're operating near the mouth of a river and you want to fly in and out of that fresh water. You can do that with this vehicle with no changes to it at all.
Okay.
So that's some of the things that make it kind of unique and able to operate in littoral waters a little bit better than traditional gliders. Yeah.
Okay.
As far as the deep operating system, there's a couple things there. We have a carbon fiber pressure hull on that system to reduce weight as much as possible. So that allows us to have a system that can go down to 6,000 meters but not be so heavy that we have to have a giant buoyancy system on it. The other kind of unique thing about that system is that it has a passive buoyancy compensation scheme. They didn't use it as the glider dove in the water. You get a mismatch in buoyancy where it would essentially get less dense as it dove through the water, and so it would slow down and eventually sort of drop to zero velocity. What we've done is we've added what we call a compressee. It's a compressible fluid in bottles that are put into some of the void areas in the glider here and aft. And this fluid compresses a lot faster than the pressure hull does, and so essentially it's compensating for the mismatch you get between the compression of seawater and the pressure hull. So it negates that whole effect of where it would lose velocity as it dove.
Okay.
So your velocity profiles are much more uniform, and it allows you to do that without transferring much oil at all. So you're saving a lot of energy by doing that. So with that scheme on this glider, the projections are the system could be in the water for about a year and a half.
Oh, wow.
On one set of batteries,
Okay.
if you were diving continuously to 6,000 meters.
Okay.